It's your turn. You can do your thing.
So, welcome to the second day of CI Days. This is one of the concurrent sessions on use your type. Cloud for the Classroom.
Okay, another one's long.
Yeah, with our speaker Tracy Ruskowski.
So I have to plug first because I have a really big bright shirt on. This is save the data, free the data responsibly, and and actually Cindy Wells, who's now the deputy CIO at the medical school, gave it to all of the enterprise architect group at ITS as a kind of a parting gift. And it's like the middle of the day, and I don't know about you, but I get grouchy when I get hungry, so lunch is right after this. So I had to find a way to like get people's attention. But free the data, yay. So basically, it's kind of neat today because we have two different things going on that I'm not heavily involved with, but got more involved with on accident. The first one is talking about how to use cloud actually in the classroom as a teaching tool and basically for undergrad students to learn about how to do research. It wasn't initially my idea. It was something I wanted to always do, but it wasn't my idea. But Professor Gus Everard decided to use Amazon EC2 in his class, and he said to me, I don't know what we're going to do, but we're going to do something. It's going to be awesome. And I'm like, okay, well, I'll try and help you figure that out. So really this presentation for the first half of the session is about what it took us to figure out how to do something like this in the classroom, some of the problems that we run into, and some of the things that we like to do in the future, given that we kind of did the trial by fire method first. The second half of the presentation is not going to be by me. It's actually going to be through Google Hangout from the Google Lead Product Manager for Google App Engine. And he's going to be joining us through the Google Hangout. So I haven't really talked to him other than emails, so please bear with us as we get that part moving, and hopefully we'll be able to get something meaningful and get some information on how you could possibly use Google App Engine in general and then for research as well. So the original concept for what Gus and I are working on is how do you take like the latest tools, like what we were just talking about in this last plenary session, and really make it something you can do in the classroom. And why would you want to do that? It seems like a lot of work to actually have to go through a real research process to be able to do something that you could maybe simulate. So why? That was like the really big first question. Well, the reason why is that because the tools today are so advanced, like some of the ones we were just watching, you can really get a solid understanding of what it means to be scalable, what it means to actually do research, and what it actually means to do research in a short amount of time. Like you don't need a huge grant and 50 people working for you to be able to do some meaningful research. And we wanted to figure out how to bring that to people of diverse backgrounds in an undergraduate situation. So some of the different lessons that we wanted to inadvertently teach in this, and this isn't something we came up ahead of time. This is literally like, what are we going to do? Okay, we found an idea. This is a great idea. Now this is all the stuff they're learning from it. So it was really kind of a creative process and a collaboration to really figure out how this was going to work and how it was going to be successful. So, we wanted people to be able to leverage previous research. I mean, how often do you really sit and say, I'm going to research something, and you never look at anyone else's previous work? I mean, you have to know how to work with previous data. You have to know how to work with code. You have to know how to work with what other people have done and how to interpret it. We obviously wanted people to get hands-on experience with the newest tools. That was one thing that was really big for Gus. He was also very into making sure that people knew how to interpret data. Like if you get all this data and it's all kind of hanging out, like everyone talks about the data tsunami, you can, say it means one thing, but what does it really mean? Like what does it mean in context of the problem that you're trying to solve? The thing that was important too is that we wanted to be able to have people have experience gaining, gain experience doing actual proposing of a research project, defending it, getting data, defending that, and figuring out how that process works. Because it's not always very straightforward, and it's not like something that you just, they do teach classes on how to write grants and how to do research, but it's something that for me, I learned a lot more by doing, and I thought that was really valuable. So, real tools, real data, real results, hopefully do something meaningful and not have to just simulate. So the actual assignment was an interesting thing to try and figure out because, as a lot of people know, Gus is an astrophysicist. He knows a lot of things about stuff that most of us don't, especially when it comes to like the atmosphere, you know, things up in space and dark matter and things like that. And what we ran into was that we had a bunch of students who were undergraduates, everywhere from their first semester freshman to last semester senior, all across all diverse majors: computer science, economics, social informatics, political science. I think there was an English major or something. I mean, everybody was all over the place, and which is good because it was a good challenge for us. So we needed to find something that was a straightforward workflow, something that we could look at data that everybody understood, that wasn't you know, very domain specific to maybe a grad student or something that they've been working with. Maybe Gus would understand universes and galaxies more than all the rest of this class would. So that was actually a really big thing to think about while we were designing this experiment for them. And were they going to be able to do it in time? And also, were they going to be able to work with a third party for their computation? Like, were they going to actually be able to go out and use Amazon in a way that was meaningful to be able to get results? So the question really came down to the dark matter, which I believe is a smattering of the Milky Way galaxy dark matter. I think that's what that is. Yeah, I was looking for something realistic. I didn't want to insult you. Putting something up there that's not, you know. But Gus had this great idea that, you know, he's like, well, I had a student a couple summers ago that was taking a smattering of data off of ratemyprofessors.com and doing STEM versus non-STEM. You know, is a STEM class harder, easier, or is the quality better or worse? And looking at that data and making some determinations on that. But it was a really great place to start because everybody in the room rates their professors. Everybody, you know, everybody's had this experience for the most part. Everybody understood the data, whereas the galaxy data was going to be, even though it probably would have helped Gus in his quest in his career, it probably wouldn't have helped us because, I mean, I could understand the math, but going into a classroom with this diverse of a student group, we needed something that we could really have be tangible. So we've settled on looking at ratemyprofessors.com and grabbing data directly from that site. So the actual project, this is just a rough overview. Basically write a proposal. Gus wanted them to do pseudocode, so what the actual process is going to look like that they were going to use, you know, the methods that they were going to use. Basically, if you're putting together a regular proposal for grants, that's the kind of thing that you'd want to do, is to be able to say, this is what I'm doing, this is how I'm going to do it, this is the result I may or may not get, and then try and justify all of those means. So that was the first piece. I believe they collected the data. Have they been? So we're not done yet. That's the other thing. It's a project for this semester, so we're still collecting information. But the idea is then take data from a known set of schools. So 2 groups in the class did Big Ten data, 2 did Pac-10. What Gus had done previously with his summer student was, I believe, OSU and U of M, and did a comparison there. So we tried to expand it out a little bit. And then our easy course is better, and looking at STEM versus non-STEM. Like, so looking at science, technology, engineering, mathematics versus, say, the languages and things like that. How do people really view those? And then report the results, which is still forthcoming. So the actual experiment, I called the experience because it's really was an experiment for us and an experiment for them and for everyone. I think it was probably quite the experience. So Pac-10, Big Ten data goes into something that we can actually collect from at Rate My Professors. Then we're going to use Amazon Web Services as a vehicle to be able to collect this data, because what ends up happening, the code that we had that came from Gus's summer student looks something like this. So it's basically just Python. It's grabbing, it's basically saying, I'm going to U of M, which happens to be number 1 something something URL, and then I'm going to grab a bunch of output and turn it into text. Well, that's fine, but what if you want to do that for like 1 million schools? So then you run into the scaling problem and the reproducibility problem of, if you have a URL in this particular piece of code that's been hard-coded to a specific number in a URL, how do you actually feed this code to make it do things automatically? Or how do you run it 1 million times by hand? I mean, that's a very realistic problem that a lot of scientists get into, is, you know, how do you really gather your data, and how do you do it in a way that's actually you're not going to be sitting at your computer for the next 10 years pushing buttons. Another thing that we didn't actually, I thought it was an interesting little gotcha, but we didn't make the students do it. It figure it out. It's more for a computer science person, but because of the way this code was written, there was really no garbage collection at the end. So when we actually started getting output, we would literally get output that started to look like this. Like we knew we didn't have all the right data coming out of all the right schools. So what happened is Gus and I kind of, remembered, oh yeah, if you use somebody else's stuff, you might want to make sure it works first, or at least, know the guy so that you can go back and talk to him. But so basically what ends up happening is you run that script. You can run it on your desktop. You can run it anywhere, but the idea is to do it in Amazon so it can be reproducible and scalable. You get names, departments, ease, quality, number ratings, and the hotness, which if you've seen RateMyProfessor.com, you can rate your professor as attractive or not attractive. It's like just a binary value. So there's also more data that can be grabbed from this. This was just a light dusting. You can do a lot more data mining on the data that comes in Rate My Professor, which is an interesting piece of information too. So I just did some quick analysis using Google Tables, just for fun. Because what ends up happening is you start looking at something like, say, math. So this, I cleaned up the data a little bit. So as you see, like number of professors is greater than 5. So that means that it's not just one person rating one professor, and that's, all that they can skew your data that way. So getting rid of some of the skew. So for this, at U of M, apparently math, on average, is considered to be relatively difficult on a scale from 1 to 5 of the professors reviewed by the students who reported. So then, what about math is it's related to the average quality. Well, average quality is actually a little bit higher. So it's hard, but there's quality. Now, where the social scientists really start to have fun is when they say, well, apparently 30% of the people that did these surveys of all the professors that were surveyed or that were reported on, apparently they're only about 30% of them thought they were hot. So that's interesting when you start to look at something like, say, the languages, where Italian's apparently very good looking, and then but then you can then you can start to see some of actually the real questions. If you looked at all the schools in the United States, and all of the perceived quality is going to affect, perhaps there's a correlation between some of these different variables, that there's just data sitting out here that nobody really looks at, other than people wanting to know if they should take a class or not. So when you start to aggregate a lot of that, it gets really interesting. And so there's a lot of other questions just besides what the assignment posed, which was, is a class hard? Or how is the hardness and the easiness of the class perceived versus the quality? So there's a lot of different things you can do there. So what actually really did we end up getting results on? So like I said, we aren't completely done. But one thing we did have a lot of problems with was because Amazon's kind of in this point of, I guess you could say, they're still not quite sure what they're going to do with education yet. We're kind of a mystery to them still. That we had some problems getting a hold of the right people. Basically, this is something everyone should know too, is that Amazon is offering grant credit on their system. So if you have a project and you want to do some work on it, they'll actually give you, credit on the EC2 Amazon system to go do whatever you want to do. So we were trying to get our free stuff, essentially, and trying to get to the right people proved to be a little bit difficult. But now I think I've got that sorted out for at least, if you want to do this, then if you come to me, I know I can get it to the right people. But that was something that we ran into that was a little bit stressful. The other thing is that right now with Amazon, you can set permissions on the different services. So I can say allow people to have access to S3 but not EC2. But at the same time, if someone on S3 decided to upload 30 terabytes, I'm paying for it. I can't set a quota limit. So that's one thing that Amazon has promised to be fixing as well, is that they'll actually have quota limits that we can set as individual users of our accounts, on individual users of our accounts for in the future. And also, that also ties into the way we do identity management. Right now, Amazon, of course, isn't under non-disclosure with U of M, so we're not doing anything fancy with using mCommunity or any of the authentication methods here, which is something that if people would like to actually use this in more mass, that would be something that we would be looking at, how to make sure that we could streamline the process of getting accounts, getting billing, making sure that you're not spending a lot of valuable class time doing that kind of work and actually doing teaching and learning. Some of the issues I think we overcame pretty easily and well is specifically finding an appropriate fit for the class. I mean, if you're doing a class that's as diverse as the one that we had, I think we found a really interesting data set where people could really look at it and say, this has got some real value to it. Figuring out what teaching and education and how it relates to some of the feedback that comes through the My Professor site. If you're doing something in, say, computer science, maybe you would want to put that in a Hadoop structure. Maybe that you take that same experiment and say, wow, you're just doing text searching. I could actually put that in Hadoop, automate a lot of it, and then it'd be a totally different handle on the same kind of experiment. So the other thing I think that we did pretty well was demonstrating the potential of big data. One of the things that you get all these text outputs when you run this code, and if you're doing it on your desktop and you only do it once, it's like 5 files. If you do that, for 1 million schools, 1 million times 5, you're sitting there a while, and you also have a lot of cluttered space. So the idea of how do you manage things that can be done on a very tiny scale, but then put to a very big, meaningful scale as well, becomes something that we're hoping that, if people don't solve it, that's okay, because we all deal with that in a scientific perspective on a daily basis. Big data is a big deal right now. But at least people are thinking about it. And the way I think about it is that if I would have been thinking about big data when I was like 18 in college, I would have a much more mature output of how I'd be thinking about that problem now. Like, I would have so much more experience and so much more brain power just churning about what that really means. And so I think if we start inserting this type of thinking into, on a very simple level, this is a very simple concept, but if you take this type of thinking and insert it as in an 18-year-old, when they're like doing their postdoc, they're gonna have a totally different understanding of what it means to do big data. So I think that's where the value can really come across here. So basically, this is from Gus's studies. So this is a plot of what happens when, at University of Michigan, the average ease and average quality of STEM versus non-STEM classes. And Gus, you can just, what was your interpretation of the?
Sure. Well, black points are STEM, red points are non-STEM, and yellow are languages.
That's right, languages.
What you can see is, and easiness is,
Easiness is such that easier courses have higher numbers, and hard courses have low numbers. So quality is self-explanatory, I hope. So there's a positive correlation between perceived easiness and perceived quality, in the sense that students perceive easy classes as being higher quality. That's one way to phrase the results. But the trend is less apparent in STEM courses. The correlation coefficient, if I remember correctly, is about 0.3. The correlation coefficient in non-STEM courses is more like 0.6, so much more significant. And language courses here take kind of a life of their own. The hardest class, I believe, was Japanese.
The highest quality class was, I believe, Japanese, but you can see it was actually harder than some of the other language courses. But the idea then is to see whether these kinds of trends are similar at other institutions, what kind of variability we will see. We don't have results yet, but that's going to come out of the studies of Pac-10 and Big Ten schools.
So, I went into it thinking, okay, ratemyprofessors.com, to be honest, I was like, well, it's what we got to go with, so let's try it. But honestly, I find this very interesting from a statistical perspective of the things that you can just grab data. Like, there's data living out in the world that no one touches that you can just freely go write code to go grab it and come up with some really, really interesting results.
Sorry, I want to point out the means of the STEM and non-STEM are those big circles.
Oh yeah, that's right. So the big red and big black dots. Let's see, where were we? Oh, wrong way. Prezi. I'll do it manually. There we go. So some of the other applications, you know, obviously we scale to different number of schools, and then maybe you want to collect data on a regular basis. Maybe you want to come up with a baseline of how many respondents you're actually getting in certain schools. Like maybe you want to do it over a year and collect samples from over a year. So that's another thing that in Amazon, the way that you would do that, you literally spin up a machine when you needed it. You could even have the API control it in some way, and then you could go grab all the schools, and then you can bring it back. So there's a lot of things that you can do to automatically control Amazon without actually having to do anything. You can do a lot of that programmatically. So, and then, you know, of course, expanding the analysis is another idea of taking the different pieces of data that may or may not be, you know, captured in a specific run and grabbing those, and actually you could even do a text analysis directly on the comments. For example, maybe you grab all the comments and you go through and you do some kind of Hadoop search for, you know, similar words for similar professors. You could find correlations in that kind of way too. So I mean that's why I really started getting into this. I'm like, well, the opportunity in here is really endless, and it's just a very, very simple example of something that you could do, given the fact that as an undergrad, you don't have to have a grant, you don't have to own a bunch of machines. You could literally just go buy some time as you're, you know, all by yourself out on Amazon, or you can get a grant, which is very publicly available, and actually do some meaningful research. So in the future, I mean, I consider it part of my job to make the streamlined billing and quota model more realistic. You know, another thing that could be done is undergraduate to graduate classes. So maybe the graduate designs an actual study, and then the undergraduates participate in it and help, you know, kind of more across lines. Because right now there's a lot of undergrad work that goes on, but it doesn't really relate necessarily to people as much as graduate work. So maybe there's something that could, you know, kind of cross boundaries there. That's a possibility. What I'd really like to see is integration into a classroom portal like C-Tools. So what if, you know, in the future, I'll get out of here. What if in the future, this is my mock-up of C-Tools and Google Sites. You know, you have your math class or whatever, and under resources, you go to resources, and you have automatically storage allocated to you. You have compute allocated to you. Maybe you would actually even have software allocated to you. Like what if you were using SPSS or SAS specifically for that class, and all you would have to do is go to your portal and, you know, say, oh, okay, there it is, obviously. And then that's like becoming a lab fee. Like it becomes that type of experience. So that's where I hope to get with it. I think that personally would be really cool. If you think otherwise, please tell me, but because that's the way I'm going. So if you think that's a bad idea, let me know, or if it's a good idea. But I think ultimately that we want to be able to make it as seamless as possible for people to use some of this stuff. So now is about that time. I am going to now attempt to get on Google Hangout with our buddy here, Greg. Greg is the Google Product Manager at, he's the lead Google Product Manager for Google App Engine, and he so graciously offered to talk to us today and give us kind of a basic overview of what Google App Engine can do for research. And now I will also demonstrate how to get onto Google Hangout. So in Google+, go to Google Hangout, and it's going to find me somewhere. There I am. Yeah, you also do it within a circle of defined people. Yep. So. Right. So rather than share with everybody, let's find him here. There he is, and he's waiting for us on the other end. So hopefully, he's not here yet. so. Maybe. Let's do this first. Well, you guys can hear that, so that's good. Sorry. You can watch me fight with this. Oh. That's better. Greg.
Do you need my help? Or are you already set?
Well, we're waiting for Greg, so he has
Oh,
not
okay.
shown up.
Oh, he hasn't? Does he know what time it's supposed to be, his time?
Yeah, well, I'm just gonna. So what I'm gonna do is, do you guys have any questions about the project that we did?
I didn't catch which particular class it was for. You said Honors 352, but what is the class? And then secondly, I'm curious about, was this project like made an honors course, or were there other requirements in the class?
Yes, so this is the second year that this course has been offered. It grew out from when Tim McKay took over the honors program directorship, he sent out an email to faculty inviting ideas for new courses, particularly in the area of natural sciences. And I thought that it would be, that was in 2009, and it was at the time when Microsoft Research had published a document called The Fourth Paradigm. Some of you may have seen this, and I thought this is a great, exposing students to the notion of the fourth paradigm would make a great class. So I put in a proposal to create a class that's called Cyber Science, and that was accepted, and it ran last year with 15 students. There's a poster actually right outside that has discusses the curriculum and has a little more information about the course. The challenge there are a number of challenges that I can talk about to standing up a course outside of the academic programs in the university. I think go back. My class is here, by the way, where I'm 12 students this year. Say hi to everyone. And as Tracy noted, these are students that come from all walks of life in LS&A. We have students who are techie, and we have students who are just curious and not techie. And I think I've always said in Physics 140 when I taught mechanics, release your inner geek. And there I was talking to engineers, so that was easy. They have an inner geek that usually is exposed already. I don't need to actually get them to release it. But in this class, I can actually try to pull some inner geekness out of my students who don't normally think of themselves that way. Last year, I think I tried to run the course a bit more like a humanities class in the sense that there was reading, there was discussion, there was more thought involved of just sort of synthesizing at an abstract level and not actually doing as much. I've since this year thought a little bit more about repurposing the course to, the byline of the course is sort of something like the purpose and practice of scientific computing. And I thought I had done a pretty good job last year with explaining the purpose, but the practice, as Tracy said, you really got to get your hands dirty to really gain something tangible about what that practice is. So last year, a couple of the things we did was we had a dissection lab where I would bring in old machines. I would bring in several old PCs, several old Macs, several old 1U boxes, and there would be a dissection of them to break them down to the components, and then you could compare across to see what are the components that are similar, what are the components that are different, how are these systems packaged. So that's one way of getting your hands dirty. Another way we got our hands dirty is to work with we did a little bit of coding. We did coding with a language called processing, which is a Java-based language that's geared towards the visual artists, and it was built at MIT Media Labs, and is widely employed by people to do a variety of visual effects and just fun things. It's intended to be kind of a fun entry into coding. And You don't write code, you write sketches. So last year we had a bunch of sketches, and this year we spent just 2 days in the lab, 1 week, in a Mac lab here in the USB next door, and students worked in pairs, in teams of 2 to design a new sketch, leveraging existing sketches that are there in the public domain. So last year, for example, we had the winning, and then we voted to see whose sketches were the best, and there was kind of a popular vote and a more of a most technically savvy winner. And for example, the popular winner last year was the Obamification of the Clintons. It's an app where you could choose a vintage 1990s picture of Hillary Clinton or Bill Clinton, and when you moused over, you got the Obamification effect in terms of that famous Shepard Fairey poster of the blue and red. It would turn the color palette blue and red. You know, simple idea, but you got to code it. And what does it take to code it? Well, you know, the usual. You got to debug. You got to spend the time. You got to design your solution and make it work. So these are just kind of skimming the surface of a very broad range of topics, including the nature of scholarship itself, follow the money, who are the players and participants, and what are their practices in scientific research. And so I think going forward, what I hope to do is to find, maybe de-scope that broadness a little bit as I see what other courses are offered in, say, School of Information or across LS&A and engineering, and try to integrate this course more into the existing curriculum. Because when you stand up a new course inside a department, usually you have an obvious place for it, and it fits in the curriculum, and then you get a flow of students that come in because they essentially have to, or because it's attractive enough that they come. But when you stand up a course like this that's standing out all on its own, I really appreciate U12 taking the burning your 3 credit hours with me this term, because you didn't have to do that. And in fact, in some cases, they're taking it not to satisfy any kind of requirement, but because they're interested. And of course, that is great. I'd love to continue, nothing a professor likes better than to have a set of students who are interested in what you're teaching and what you're trying to get them to learn. So that aspect has been extremely positive. I don't know, while we have time, let me turn, if you'd like, we can turn the mic over to a few students and get their impression of what's working in the class right now, what could be improved, where they see this class heading. Unless there's another question that I can answer, and unless Greg shows up. Has Greg shown up?
Yes, he's here.
We're
now.
almost got it.
So let me put some of my students on the spot. Chad, Chad is a senior, social informatics major, and
Here we go.
I'm going to ask you perhaps to just freeform. Tell us about your experience so far in Honors 352.
I was going to say, if you can go to the other link that I sent, can you hear me?
Oh, sorry. We were spinning time while we were trying to figure this out.
Oh, no problem. If you could go to the other link that I sent, then it's actually, we can present and everything there.
Yep, give me a second. I'm going to mute you, and then they're doing some other stuff in the background. So.
Perfect. Thank you.
All right. Well, I'd first gotten an email about this class sometime last year as an elective for informatics, and it just looked really interesting. So I contacted Professor Gust and told him about my background and just wanted to find out a little more about the course. And it turns out it is a perfect match for like social computing in informatics.
Big display.
Anybody?
So I'm actually a chemistry major, and I don't know, I was interested in learning more about technology. I'm one of the non-techies that has absolutely no idea. Sometimes I'll have trouble accessing things just on C tools. So it was interesting for me just to learn about how computing developed from the lecture side and from the readings that we had to do, and then actually getting hands-on experience with learning a little bit how to program and stuff. It was really cool. So it's been interesting.
Like Christian as well, I do not know anything about technology before this, and I appreciate this class so much in terms of we did one paper, and I did about supercomputer and relations of supercomputer in financial world. It was absolutely my thing. I love it so much. And we are now working on a project that we showed it just now. It's good to have that in mind, that we can relate everything in our daily life. I use readmyprofessor.com, and I'm doing it right now. I'm a researcher in this class. It just makes me feel so good. I really appreciate this class because I have a really good teammates. They know everything. They are here to help me. And I'm here absorbing what they have. So thank you.
Oh, I'm Ken, and I'm also an informatics major. And I think this class is especially relevant for our generation as students here, because we're in like a time of history where cloud computing, all these technology is getting developed. But I feel like most of us, in terms of cloud computing, don't really understand it. So having this project to do like hands-on experimentation with this cloud computing helps us understand like the capabilities of it and how it's going to develop in the future. So.
Kind of going off what Ken said. I'm Lorenzo. I'm a freshman, currently undeclared. I think that you're starting to, like right now, we're starting to hear more about these, about big data and cloud computing, and I think this class really helps sort of explain sort of like the nitty-gritty behind it, which I think is really helpful. Sometimes I wish that I had maybe taken I had taken this class as a sophomore or something like that, just so I would have had like more sort of hands-on programming experience at first. But I think this is a really great sort of introduction to computing.
Hi, I'm Ian. Yeah, I agree with what Lorenzo said. It would really help to know a little programming before getting to this class, but I think it's been a really great introduction to the network of technologies that's behind science research right now, and otherwise I probably would never have been introduced to it.
Well, I'm Randy. I guess I come from the other side of things. I'm a CS major, CS and math, and I'm a senior. So I'm pretty used to like coding and that sort of thing, and I get exposed to it a lot. But I find that in coursework you're very exposed to very nitty-gritty details, implementing code, and this class really gave me an opportunity to sort of look at computing, look at technology from a more holistic perspective, and look at the big picture where things are going. And I think it's really given me a great perspective on kind of what I want to do with my life in terms of technology.
My name is Andrew. I'm like the lone poli-sci guy. I come from a military background where I work predominantly, basically as a network engineer, and I have to echo the idea that this course presents cyber infrastructure as a multifaceted, whereas I know a lot about transmission systems or things of that nature. I can't code to save my life, and that's an important part of cyber infrastructure. So I would say that definitely for the course in the future, maybe a better knowledge or presentation of coding would be useful. But overall, I think this course has been highly successful in introducing cyber science as a multifaceted and fascinating discipline.
Hi, I'm Austin, and I'm a freshman here. I think this class is super interesting, and it's super relevant because we see in the news all the time about all these new big data companies and these new IPOs coming out, and I think it's a super relevant class that is like a perfect time for it.
That was not rehearsed.
Yeah, you guys are awesome. Technical difficulties covered. That was like extra credit, right?
Well, we didn't hear from everyone, so there's a couple more.
Yeah, they
There's actually 3 more left.
Well, I
think that's all.
My name is Devin Rocco. I'm studying computer science. I'm a sophomore. And I found this course very interesting looking at the background, like the history of computing, because my father also studied computer science, and he has actually worked in Fortran, some of the other older languages. But obviously, the internet revolution is something that's kind of not exactly confined to our generation, but something that we're really exploring a lot more in cloud computing. So it was very interesting looking at the history of computing and also where it is now and maybe what it can do in the future with big data and all that sort of stuff. I'm going to pass it on.
So we found our Google friend, unless you want to, he knows to wait a minute, so.
Okay, I hesitated to say hi, and I waited to be one of the last people because I'm a little shy at the mic. However, what I think has really paid off in the class and what I've really taken away from it is this notion of big data. Very rarely as an undergraduate do you ever work as a research assistant, or do you ever work on projects yourself that involve thousands of data points. And it is then that I've really realized that when you're looking at thousands of data points, it's very impractical to use something like Excel. Just flipping through spreadsheets and different files to actually look at some of the summary statistics of those. And so that's what really necessitates the actual practice of coding and making sure your code is right in order to study these things. And I've never really been approached with that idea before.
I'm Morsi. I'm actually on a pre-med focus right now. And speaking of relevancy, obviously big data is encroaching into all fields of science. So I found this class very enlightening on that subject, and I feel like I know a lot more.
Thank you, guys.
Okay, now, thank you guys for helping us out with the technical difficulty side dance. So now we have Greg. Please pronounce your last name because I'm scared of it.
A lot of people are. Galasandre is the nice way. Galasander is the American way.
So, yep, you have the floor, and I already told them that you're the product manager of Google Apps Engine right now at Google, and they're just looking for a basic overview of what Google Apps is and how it may or not be important for them for research.
Sure. So I'd also like to introduce on the other screen over here.
I feel like I'm on the Brady Bunch or something.
Any chance that you could point your camera out so we can see who is in the room?
Oh. I'm kind of attached, but...
Oh, no problem. Excellent.
Yay.
All right. Well, thank you very much for giving me a chance to chat with everyone today. And sorry about the technical difficulties. We'll figure out those issues next time. One of the things we wanted to try to do is actually give you a demo of Google App Engine. But before we get to that, I think the place to start is talking about what a platform as a service, which is what App Engine is, and why these came about in the industry. Very early on, and what you guys are probably accustomed and used to using is building your own stack. If you're going to, I guess the first thing is, how many here are developers? How many people here write code? Okay. How many of you, you're holding the laptop, aren't you?
Now I'm above it.
How many of you here have used what's called a platform as a service or a PaaS? Okay, fair enough. So if you're developing code, before platform as a services came out into the market, what would happen is you would you would, get a machine, probably sitting under your desk, and you would start, and you obviously have an operating system, probably going to be some flavor of Unix. You'd start running what people refer to as your own stack on that machine, which basically meant that you had to have web hosting. You typically had to have a database. A lot of people will refer to something referred to as a LAMP stack. This is something you might have heard, which is Linux, Apache, MySQL, and PHP, which is a number of technologies that people sort of assembled, made it relatively straightforward and easy to launch on a thing. But it still meant that in order to write code, A, you needed actual hardware resources to deal with, and then B, you needed to maintain this. And so if this is something you wanted to write code for and run once, that wasn't so bad. But if this is something that you wanted to be running permanently, so that you could access it whenever you wanted, anyone could access it anywhere, started to scale, that started to become a problem, because it meant that you had to then start to understand how to apply patches, all this kind of stuff. So App Engine was started about 5 years ago and was one of the first platforms and services created. And the reason it was created was there were 4 guys at Google. They all went to college together. They were working at Google, and they were like, we really want to work on something together. And then they all realized they all hated maintaining this stack that I referred to. They didn't like doing the day-to-day maintenance work. They liked writing code. They liked building things that got stuff done, but they didn't like the maintenance. And so they came up with this idea of, could we build something that meant that we don't actually have to deal with all the maintenance. The maintenance can, the maintenance just happens. It's, there's somewhere someone is running the system, but I don't have to know who they are. I don't have to deal with them. And that's where the idea behind App Engine and platforms as a service in general is born. Is you want developers to be able to, using war analogies, I know is always the worst thing, but fire and forget their code. So you write your code, your code runs, and then you can tweak your code, but you don't actually have to spend a lot of time figuring out, like, oh, in order to to scale up to a larger user base, or in your case, it's probably going to be to scale up to running more queries. I have to do all sorts of crazy stuff to my database to get it to expand, and for any of you who've ever tried to expand a database, it's a big pain in the butt. So the idea was, rather than worrying about those logistic stuff, just let you write your code, and then we essentially have an architecture that allows it to expand to fill whatever needs that you have. So, and this is sort of the concept behind platforms as a service. You'll also hear terms like infrastructure as a service. Some of you might have heard of Amazon EC2. And what this is this gives you essentially, that LAMP stack I referred to, where you want Linux, Apache, MySQL, and PHP. Well, what Amazon EC2 gives you is, in essence, it gives you the L, right? So it gives you an operating system that you can then run whatever you want on top of. The nice thing about infrastructure as a service is it gives you a lot more flexibility. Because if you just have an operating system, you can do anything you want to that operating system. The downside of it is it means the AMP part, you still have to manage yourself. You still have to worry about patches for security purposes, that kind of stuff. And at the point that you want, that you're running something that'll take more than one machine, you have to go in and configure a second machine, and then probably configure a load balancer and figure out how to get the traffic between those two machines. Platform as a service essentially takes all of that complexity away. And what it does is you write, and in the for the case of App Engine, you write Java code or Python code. How many of you have experience with Java or Python? Excellent, great. So you take Java code or Python code. Now we essentially put some enforcement in place. Again, I'm using all the bad things. War analogies, talking about enforcement, all the things everyone loves. but we have some enforcement. It essentially means that the way you write your code has to be done scalably. Now, I know that sounds that sounds challenging, but what it basically means is the way. Did you all see a banner that says Ayin is now watching YouTube? Ayin, are you watching YouTube?
I was actually queuing up.
Oh, okay, great. I was like, I'm so bored that Ayin doesn't even want to listen to me. So the way App Engine works is that you essentially have to write your code so that in general it's basically stateless. And what this means is that in the case of Java, we spin up a JVM for you. We run your code in the sandbox. And this means that you're sharing resources with lots of other applications running. But when I say sandbox, what it means is your application can't break out of this container we put it in. But at the point that you need more resources than that one container, we then spin up a second JVM, or a third, or in some cases of some of our customers, tens of thousands. And we spin it up automatically based on the amount of traffic that's coming into your application. We then have a layer underneath it called data store, which allows you to persist data. So these JVMs, they spin up and spin down based on the amount of traffic that you're sending to the application, depending on what you're doing. But this layer of data store is where you store the data. So you do a calculation, you get a value that you want to keep forever, you write that out to the data store.
And it's probably worth pointing out that the data store is like a non-SQL, non-related data store.
Very good point. So, and how many of you have had experience with SQL? How many of you have had experience with NoSQL? And I know that seems like it should be a complete set. Everyone has experience with SQL or NoSQL, but NoSQL is a different type of database. Okay. So data store is something that is called a NoSQL database. And basically what this means is a SQL database allows you to do essentially arbitrary queries. A NoSQL database is key value pairs that have indexes on it. So you can search for things, but it's not, you can't do arbitrary queries. The reason that NoSQL is actually, in many ways, better than SQL is because it'll scale indefinitely. SQL ends up, the amount of time it takes you to get a result back from the query is based on the complexity of the query and the amount of data in the database. And this means as your database gets larger and larger and larger, your queries get slower and slower and slower.
The other big difference, I think, is the data store and most non-SQL databases are schemaless, which means you don't really have a set of columns that are enforced, whereas in a SQL database you have a rigid schema. And if you want to add a property, you want to add a field, you have to modify all of your rows versus in NoSQL, each entity or row has different properties dynamically. So it makes a lot of different development by sector to build your app.
And tying this back to what you guys are interested in is sort of how to use it for research. This is something that might actually be, I imagine you'll be dealing with very large data sets that you're trying to walk through. There's something that runs on App Engine called MapReduce. I don't know if you guys, I know I'm asking lots of questions, but how many people here know what MapReduce is? Excellent. All right. So MapReduce is a framework that essentially allows you to fire off a big job and consume it, and the way it works on App Engine is it consumes as much resources as you need to get the job done. And it can, I won't go into a ton of detail about what MapReduce is, but essentially what it allows you to do is it allows you to go through and find the data you need in a large data set, and then process and do something with that data. This is something that is used very heavily at Google because we're often dealing with really large data sets. And you know, it's funny. Before I started working at Google, I thought I dealt with really large data sets, and then you deal with things like every log entry for Google Groups over the course of the last 3 months. Turns out that, you're talking about billions of entries, so you need a framework that allows you to quickly get information, so it's not going to take, multiple days or even weeks to run over that data set. You want to get a response within, ideally, minutes to some of those things, and sometimes hours. And so MapReduce is a tool that is often used when we have a framework running on top of Appen for using MapReduce. So these are some of the tools that are available. I mean, you said you had a demo video queued up.
Yeah, we can try this. We'll see how it works. It's unclear. I mean, I can't share my screen.
Right.
So from try to do this experiment, let's see what happens. It may not work. I have a video here. This is a great, if you have time and you want to spend like 10 minutes learning about Appen, this is a video that was, well, let me see if I can use this. This is not going to work. I wanted to show, this may not work.
Yeah, so it brings up a banner that says, do you want to switch to YouTube? But I think we could watch it at the same time.
Yeah, it brought it up, but it didn't give any buttons.
You have to click down at the bottom where it says YouTube.
Okay, well, all right.
Oh, maybe we have to control it.
Yeah, so you're not.
We all are very familiar with all of this technology. We use it all the time. It's really.
Well, no, I mean, this is sort of an experiment.
Yeah.
You're not seeing my video.
Are you guys seeing it play?
You need to click on YouTube.
Try this. If we clicked on the button at the bottom that says YouTube, and it didn't do anything.
All right. Well,
All right.
This is not. Well, let me just explain then. Let me cancel this. Let me sort of explain conceptually. So, there's a couple of different components to App Engine, and we have a local SDK, software development kit. It's about a 10 to 30 megabyte download depending on if you're programming under Java. You install it, and it's installed on Mac OS, Windows, Linux, and it gives you everything you need to get started with the building application. So essentially, it emulates what our production service look like, our environment. So you're able to download this SDK and in a few minutes basically start writing your application in Python or in Java. And if you're writing in Java, for example, you might just be writing servlets. So it's going to look and feel familiar to you. And you can basically run a prototype application. We've emulated the data store locally as well, so you can build your entire application locally. You can test it, run it, and then you're ready to deploy and push it into Google's infrastructure. There's essentially a button you'll press. It'll ask for your credentials, and it will take the code that's running on your desktop, push it into Google's cloud, and then literally within 15 seconds, live traffic is loading off of that application. So what that means pragmatically to you is that you can get an application into the cloud serving traffic at a lot of load in less than 3 or 4 minutes, which is pretty powerful, without having to manage machines, without having to manage any complex infrastructure. As Greg mentioned earlier, there are constraints. You have to work within the constraints of the sandbox. But once you understand those constraints and work within those constraints, it's really easy to build, test, run, push, and deploy an application into the cloud and be productive. So you're spending your time on that pitch app engine. You're spending your time focusing on your application and on the stack. So build your app up. And that's one of the reasons that you might care about. You have some research stages trying to do really common applications, trying to cast or connect to other systems, to make it really easy to get something into the cloud. The one anecdote I'll give you is that I was talking to Appen at the really long insurance company at one point, and they told me that for them to build a new application and get any traffic running on it, it took them 3 months just to get a machine provision on their network and get a firewall port vision. So if they wanted to build an application that did something, it took them 3 months just to get the machine provision, and then they could basically just start writing code. With that engine, you can do all of that in a matter of minutes. That's part of what is powerful about it. So I'm sorry I can't show you, but if you can see what I'd like to show you, you can sort of conceptualize and get it. But there's a great video, the one I just showed. Just go to Appen.google.com, it's on the homepage. 10 minutes, and you get a really good sense for what it's like to code and going after it.
If you
No.
guys send me links, I'll make sure that it gets posted to the general populace. So.
Perfect. Now I know it took us a little while to get to get the technology set up here, and you guys probably had limited time, so I don't know if you want to ask questions. How much time do you have?
We just have about 5 minutes for questions, so let me grab a mic and you guys. Hello. Does anybody have any questions for these guys?
Be anything in the cloud.
Was this helpful?
I think we're all still really. Well, I can talk right to you. I think for me at least, like I'm getting over like my head's in a box. My head's in a box. so it's like we've been using this for our meetings and stuff like that, and I think it's going to take us a little while to get completely fluent with using. We use Hangout quite often, and I think this is probably the first time a lot of people have seen Hangout. So I think that in itself is just like, oh.
Hey Tracy, ask him to say a bit more about what kind of applications.
Yeah. Okay. Yeah, everybody wants to know a little bit more. Who put the mustache on?
I wanted to point out we've actually built apps that interact with Hangout.
No, everybody here wants to know more about what type of application would be a good fit for App Engine.
That's a great question. So why don't I just rattle off a couple. So just real quick, let me give you a sense for who's using the platform today. So today we came out in 2008. We have over 100,000 active developers building applications on the platform. We have 300,000 plus active applications running, and we serve at Google over 2 billion daily page views on App Engine. And so it's one of our largest properties in terms of actually serving content. So there's lots of developers building on the platform, external developers, and then we also internally use App Engine to run different applications out to the world. So, for example, there are essentially 4 classes of applications that we see people building applications, building apps. The mobile tablet applications, so lots of iOS, Android applications. They need to be able to serve assets or be able to store profile information, profile information synchronized. We see social mobile games, lots of social mobile games in App Engine. If you've ever played Angry Birds in Chrome, that's a great example of an application that was built using Google App Engine, Play and Framework, which is of course gaming framework. There's Google Plus integration, and that whole game was served and hundreds of thousands of people on it. You see lots of consumer web applications. So, for example, a great example of an app that we use on App Engine is Khan Academy, which most of you may or may not be familiar with Khan Academy. It's essentially a free way to. There's lots of education at scale, is the way I think about it. And there's a course, curricula you can follow, really, really good platform to get really great content. Business to consumer, so there's companies like Best Buy that use App Engine. The Royal Wedding is another example of a great application where they didn't know exactly how many people were going to be viewing the wedding and want to interact with it, so they built this application and we scaled to millions of users, 32,000 peak queries per second. We have 13 million people run that application.
And I think one of the things that I am highlighting is applications. One, you're not quite sure you're going to be getting. And so what you want to do, you don't want your application to essentially fall over if too many people go to it. And for some people that means, is it 5 or is it 20? For some people that means, is it 5 or is it 20,000? Either way, so if it's 20,000, it ends up costing some money. If it's 5 or 20, it doesn't cost anything. It's free to get started. You can just go to appengine.com, sign up for an account, upload code, start running things, and you can have 10 free apps that you don't have to pay for, and can just run your code. So when it's something that you're trying to do that you just don't know how much traffic you're going to get, it's really well suited for that.
All right, guys. Thank you very much for putting up with our technology on this end, but we're hungry because it's lunchtime.